Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve paper 4. We all call it alternative to practical ATP paper. And today we have selected October-November 2022 4-1 paper. This ATP paper, this paper 4, belongs from the zone 1 or the variant 1. So let's start today's paper, and here we go. So on your screen, this paper is showing up October-November 2022 4-1 paper. The time allowed for this paper is 1 hour. He says a student measures the refractive index of oil. Oil is poured into a semicircular transparent plastic container as shown in the figure 1.1. The container is placed on top of a 360-degree protractor as shown in the figure 1.2. So this is that plastic container. It is filled with the oil, and then we have placed it on a 360-degree protractor, and you can see this here. So then their question is, the line AB shows the position of the flat side. They're talking about this AB, and a flat side of the plastic container. A ray of light is incident at the midpoint of the AB with an angle of incidence. Angle of incidence is 30 degrees as shown in the figure 1.1. State one property of the oil that is needed to ensure that the experiment works. You see, this angle here, this is the normal at that position. This angle here, this is how much? They have told us this angle is 30, and we can also calculate this. This is 10, 20, and this is 30. This is the normal. And this is the normal line. So this container has oil in it, and we want the light to pass through that oil. So the one very important thing that oil should have, that the oil must be colorless. There should be no color in the oil so that the light can easily pass through it. Oil should be colorless. The oil should be colorless. It should be transparent. Okay. Okay, then their question is on the figure 1.2, measure the angle of refraction of the R of the light in the oil. Okay, so the angle of refraction is this angle. Okay, this is the angle of refraction. So how much is this? This is 10, 20, 21. So the angle of refraction is how much? It is 21 degree. The angle of refraction is 21 degrees. So I hope you can see this is 21 very easily. You can measure from the protractor, which is shown in the figure 1.1. Then B part, he says the student repeats the procedure described in the A and measure the angle of refraction R for angle of incidence I. And he took 15 degree, angle of I was 15 degree, 45 degree, 60 degree, and 75 degree. The results are shown in the table 1.1. For 30 degree, it is 21. Okay. Complete the table 1.1 with your value of R from A, second part. And on the grid provided in the figure 1.3, plot a graph of the R on the y-axis. So they want the R to be on the y-axis and I on the x-axis. And the I must be on the x-axis. And start your axis from the 0, 0, draw a smooth curve of the best fit. Okay, so it's a 4-mark question, and this is the table. The I value is going from 15, 30, 45, 60, 75. So 10, 20, 30, 40, 40, 50, 60, 70, 80. Okay, so that will work. And this goes up to 45. So 10, 20, 30, 40, and 50. Okay. So let me show you. I have done this. You can see this, and here you can see we have drawn this. So at 15, put a dot of 11. Then at 30, put a dot of 21. At 45, put a dot of how much? 31. At 60, put a dot of 39. That dot is here. And at 75, put a dot of 45. And then draw a smooth curve. And you can see this curve is like this. It's a 4 marks question. And one thing is very important, that you have to label this thing here. This is R, which is measured in degrees. And this is I, which is also measured in degrees. So these are very important things. This is very easy graph. I hope you can draw this. Okay, this is the marking scheme. And you can pause the video. You can you can take your time with this. Okay. Then their question is, describe the relationship between I and R shown by the graph. If you look at this graph is not a straight line, it's a curve. So that means when you, it's not a directly proportional relation. But when you increase I, the R is also increasing. So that is what we will write there. As the angle I increases, the angle R also increases. As the I increases, the angle R also increases. You can see the marking scheme as well. Use your graph to find the value of the R when the I is 50. Show on the graph how you determine your answer. Okay, so when the I is 50, what will be the value of the, so when the I is 50, so here we have, when the I is 50, this is the value. I hope this is the question. Yeah. So what is the value here? That is 31, 2, 3, 4, 34. Yeah. The value of the R will be 34. Actually, you have to draw a line on your graph. Actual graph, draw a line like this. So that shows that the R value is 34. Yeah. Okay, then their question is, they say that the theory suggests that the refractive index N of the oil is given by N is equals to sine I by sine R. Using I and your value of R from the B third part, calculate the value of N, give your answer correct answer to an appropriate number of significant figures. Okay, so very simple. The I value is 50, the R value is 34. Just put the values in this and you will find the value of the R. So here we have this N is equals to sine I by sine R. So that N is equal to sine 50 divided by sine 34. When you enter this in your calculator, the answer you will get will be 1.36, which is approximately 1.4. So the refractive index is 1.4. So our answer is right. 1.4. Yeah, our answer is right. So let's go to the next part. He says, fifth part on the figure 1.4, sketch the graph when the sine R is plotted against the sine I. No calculations are required. So the graph will be, this value is because this is sine I by sine R. So sine R by sine I, try to understand this thing. Sine R by sine I, that will be something like, you know, it will be like 1 divided by 1.4. So the line you will draw, its gradient must be less than 1. So the line must be something here. Okay, the gradient must be less than 1. So here we go. The graph should be like this. Okay, straight line through the origin. Okay, what is that? That's what they are saying. Okay, so just one reason why the practical method used in this investigation might not give an accurate value for the N. You see, we thought that the refraction is only happening in the oil, but the oil is inside the plastic container. So when the light passes through that plastic container, in the plastic, also the refraction of the light is taking place. The one reason can be this. Another reason is that the protractor you are using, that is only correct up to 1 degree centigrade. So these are the reasons. Let me show you my answer. Light passes through plastic container, so it is also it is also refracted in, so the light is, so here we should write light. So the light here, the light is also refracted in the plastic. Reading on the protractor is accurate up to 1 degree centigrade. So let's have a look at the marking scheme. On the marked plastic container will change the measured value. So our answer is right. Okay, so let's go to the next question. The next question coming up on your screen is question number 2. He says, a student investigates the cooling of water. The apparatus used is shown in the figure 2.1. So here we have a 500 centimeter cube beaker. Here we have 250 centimeter cube beaker. In both of them, the water is up to the volume of the water in both the beaker is 200 centimeter cube. And we have a thermometer, we have a stop clock, and the student poured 200 centimeter cube of hot water into the 500 centimeter cube beaker, place the thermometer in the water, stirs the water, measures the initial temperature of the water, uses the clock to find the time taken for the water to cool by 5 degrees centigrade and by 10 degrees centigrade. Repeats the experiment 3 times. Explain why the water is stirred before taking a temperature reading. Before you put thermometer in it and you take note down the reading, we stir the water to make sure that the whole body of the water is at a uniform temperature, or throughout the water the temperature is uniform. Water is stirred to make sure the temperature is uniform throughout the water body. Okay, so this is our answer. So this is the answer. To ensure all the water is the same temperature, so our answer is right. Okay, explain second part. The student uses 200 centimeter cube of hot water in the same beaker in each test. State one other experimental variable that the student keeps constant to make a fair comparison of the 3 sets of the results. You see, every time you take the reading, you make sure that the initial temperature from where you note down the 5 degree drop in temperature or 10 degree drop in temperature, that initial temperature of the water in all the 3 cases should be same. So the initial temperature, we think that make sure that in each experiment the initial temperature is same. Initial temperature same, starting to say temperature of water, and the room temperature should also be same. Yeah. Okay, so our answer is right. Okay, the B part, question number 2, B part, he says, table 2.1 shows the results obtained by the student. Okay, so for 5 degree, 82 seconds are taken, 84 seconds are taken, 83 seconds are. For 10 degree, 173 seconds, 184 seconds, 185 seconds, and the average is 181. Okay, the question is complete the table 2.1 by calculating the average time taken for the water to cool by 5 degrees centigrade. Give your answer to an appropriate number of significant figures. Okay, so I will add up 82 plus 84 plus 82 equals to divided by 3 equals to. This is how you take the average. So the average time will be 82 plus 84 plus 82 equals to divided by 3 equals to, that will be 82.66, which is approximately 83 seconds. So in that table, I will write 83 seconds. 83 seconds. 83 seconds is the right answer. Yes, sir. 83 seconds is the right answer. So we have completed that table. Then question number 2 and B and second part. Suggest one reason why the time taken for the water to cool by 10 degrees centigrade is not double the time taken for the water to cool by 5 degrees centigrade. You see, as the temperature drops, the difference between the temperature of the hot water and the surrounding or the room temperature, that difference decreases. When the temperature between the hot body and the surrounding decreases, the rate of the heat loss from that hot body also decreases. That's why the time taken for the drop of 10 degrees centigrade will be more than the double time of the 5 degrees centigrade drop. I hope you understand. I have written this answer also. As the temperature drops, the temperature difference between water and the surrounding decreases. Due to this, the rate of heat lost from water decreases. So in case of 10 degrees centigrade drop, time taken is more than double time taken for 5 degree centigrade. So this is my answer. So he says initial temperature is not as high, smaller difference from initial temperature to room temperature. Okay, so our answers are right. This is my answer. Okay, then we have the question number 2, and it's C part. He says the student repeats the experiment using the 250 centimeter cube beaker. All other experimental variables remain. He before in my first part, what he did, he used 500 centimeter cube beaker and poured 200 centimeter cube water in it, hot water. And now he is going to use only 250 centimeter cube beaker. That beaker will be smaller. All other experimental variables remain the same. Table 2.1, 2 point shows the average time taken for the 200 centimeter cube beaker to cool by 5 degrees centigrade, and by 10 degrees centigrades are shown. So here the 5 degrees drop in temperature will take 110 seconds, and for 10 degree centigrade drop it will take 250 seconds. Describe the difference in the cooling of the water in the two beakers and refer to the results recorded in the table 2.1 and table 2.2. You see, here it took 80, how many? 83 seconds. So 5 degree temperature drop take 83 seconds, and here it takes 110 seconds. Here it take longer. Here the 10 degrees centigrade drop in the temperature takes 181 seconds, but here it takes 250 seconds. So we have to bring these readings in our answer. We have to give the reference of this in a beaker of 250 centimeter cube. 5 degrees centigrade drop takes 27 seconds longer as compared to 500 centimeter cube beaker. 10 degrees centigrade drop in 250 centimeter cube beaker takes 69 seconds longer as compared to 500 centimeter cube beaker. And so this is what they have written. Our answer is perfect. Okay, so now we are going to the second part. Suggest a reason for the difference. You see, in the 250 centimeter cube beaker, the surface area of the water is smaller as compared to the surface area of the water in the 500 centimeter cube beaker. You see, when the surface area is smaller, the rate of evaporation will become less. So the heat loss from the surface will become less. So that's why it will take longer time to cool down. So I hope you understand what I'm saying. And he said, in 250 cubic centimeter beaker, the surface area of the water is smaller as compared to the surface area of the water in the 500 centimeter cube beaker. And this decreases the heat loss from the surface area different of the water. Okay, so our answers are right. I hope you understand. Question number 3, he says a student measures the density of a sample of modeling clay. So he's using clay, like Play-Doh. The clay is modeled into a cube as shown in the figure 3.1. So just one difficulty the student finds when modeling the clay into a cube. You see, in the cube, the length, width, and height, all dimensions are equal to each other. All the edges are perpendicular to each other. So when you are using clay, and you can look at this diagram also, the edges are not straight. So to make the edges perfectly straight, that is very difficult with the clay, and to make the edges perpendicular to each other is also a little difficult. So here comes my answer. Making straight edges and mutually perpendicular to each other with clay is difficult. That is my answer. Difficult in getting all three dimensions the same. 90 degree getting square corners, straight sides. Clay not easy to mold. It's stiff. Okay, so B first part, question number 3, B first part on the figure 3.1. Measure. This word is very important. The word is measure. When he says measure, you use a scale and you actually measure the length of D of one side. So with the help of the scale, measure this one. I have done this, and when I measured it, it was 2.4 centimeter. It was 2.4 centimeter. And then their question is calculate the volume of the modeling clay using the equation. This is B second part. V is equals to D cube. So the V will be equals 2.4 and raised to power 3. And when you take 2.4 raised to power 3, it is 13.8 centimeter cube. 13.8 centimeter cube is the right answer, sir. Okay, then he says the student, that's the third part of the question number 3, I think B part is third portion. And the student uses the balance to find the mass M of the modeling clay as shown in the figure 3.2. And here the mass is 36.3 grams. Calculate the density of the modeling clay using the equation. So the density is equal to mass divided by volume. We know the mass is 36.3 grams, and we know the 13.8 is the volume of that cube. So, you know, the density is equals to mass divided by the volume, 36.3 divided by 13.8. And when you enter this in your calculator, you get 2.6 grams per centimeter cube. So the answer is 2.6 centimeter, 2.6, and the unit is gram per centimeter cube, because they ask us to write that 2.6 grams per centimeter cube. This is the answer, sir. And if you look at 2.6 and grams per centimeter cube is the right answer. Okay, so we are going to the next question. He says a student that's question number 4. A student investigates the current in a resistor of fixed resistance. The following apparatus is available: ammeter, electrical connecting leads, a resistor of fixed resistance, lamp, switch, variable resistor, 6-volt battery, LED, and voltmeter. State which piece of apparatus is used to measure current. For measuring the current, we use ammeter, and ammeter is always connected in series. Okay, and here we write ammeter. The answer is ammeter. Okay, then they say the student, that's the question number 4B, first part. The student measures the current I for a range of potential differences. Draw a circuit diagram to show the circuit the student uses. You may use some or all of the apparatus available. Okay, so we are going to use the battery, we are going to use the ammeter connecting leads, we will use the variable resistor, that fixed resistor, and we will use a voltmeter which will be connected parallel to the resistor. Okay, so this is the circuit we are going to draw. We are going to use ammeter series circuit with power supply and resistor, ammeter in series and with power supply, variable resistor in series with the fixed resistor. Okay, so what we will do, then there is that's the diagram, and then we have the second part. He says describe how the student obtains different values of the potential difference across the fixed resistor. So what you will do, when you start this experiment, make the resistance of the variable resistor maximum, note down what is the reading on the ammeter and the voltmeter. Then gradually decrease the resistance of the variable resistor, and each time you decrease it, then note down the respective value on the ammeter and the voltmeter. So because whenever you will change the reading, the resistance of the variable resistor, the reading on the ammeter and the voltmeter, both readings will change, and just note down. Okay, so in this way you can get several sets of reading of ammeter and the corresponding value on the voltmeter. Set variable resistor at maximum resistance. Note reading on ammeter and voltmeter. Gradually decrease the resistance of variable resistor. I chose resistor. This word is resistor. And note respective reading on ammeter and the voltmeter. So adjust the variable resistor. So that is what we were talking about. You can pause the video, you can take your time with the marking scheme of the question number 4. So that's it. We have read the end of the paper. So all the pages are blank. It's a very important habit to check all the pages to make sure that you have missed nothing. Okay, so my dear students, in this video, I have represented you the solution of the alternative to practical paper of October-November 2022, 4-1. So I have tried my best to explain you the concepts. I hope this video will help you. It will make your life, your parents' life, your teacher's life a little easier. If you think that this video has helped you and it can also help your junior students, your senior students, please share the link of this video with them by sharing the link of this video onto your Facebook and onto your Instagram and onto your Twitter accounts. When you do this, this helps me to promote my channel. Also, please subscribe my channel. My name is Ferhan Mazher. I think it's a great blessing for me that I can make these videos and I can upload them. And one very important thing, a lot of people ask me, the viewers have asked me that the videos on the space physics, which I have made, and I'm still working on them, from which books I am making them. I have shared the PDF of those books, and you can find they are on my Google Drive, and I have shared the link of the Google Drive. If you go to my channel, there is a word community, and in the community I have written the link of that on that Google Drive. You can find those books there. They are PDF. You can download them, you can use them in your class, and you can read them. So thank you very much, everyone. Have a good day, and God bless you all.